In this problem, we want to take the integral of these rational function 2x plus 3 over x squared plus x minus 2. Rational functions are basically functions which are like a fraction, something over something else, the numerator and the denominator part. And because it's a rational function, one of the methods that should come to mind is integrating that by applying partial fractions. And the idea of partial fractions is writing these a little bit complex fraction as two separate simpler fractions that are added to each other or subtracted from each other, like just summation or subtraction. And to do that, we need to be able to factor the denominator. So if I cannot factor the denominator, I need to think about other methods like trig substitution. So let's see how we can uh, decompose this denominator. So first, let me just write the fraction. Again, right now we don't focus on the integral, we just focus on this rational function. So we have 2x plus 3 over x squared plus x minus 2. So we can write that as 2x plus 3, and denominator can be factored as, so I'm looking for two numbers which are multiplied to -2 and added to positive 1, the coefficient of x, which would be x minus 1 and x plus 2. So now that I have the denominator factored, I can write that as a summation of two fractions, which one of them has a denominator x minus 1 and the other one has a denominator x plus 2. Because later on, when I add these two, the common denominator would be what I have here. But what are the numerator of these two fractions? Since I don't know what they are or what they should be, just leave them as a and b as two unknowns. And now my goal is figuring out what a and b are. So to do that, now let's just combine these two. Let's add them with each other. So again, the common denominator here would be x minus 1 times x plus 2. And the numerator of these, because the denominator is multiplied by x plus 2, the numerator also has to be multiplied by x plus 2. So it would be a times x plus 2. And for this numerator, the same thing. So the denominator is multiplied by x minus 1. This numerator has to be also multiplied by x minus 1. So overall, it would be b times x minus. Now, if I want to be able to write this fraction, this rational function, as a summation of these two simpler fractions, I need to find a and b. And the way that I kind of need to find a and b is making sure that this is same as what I started with. So basically, I need to make sure that the numerators are same because the denominators are already similar. Actually, we started in a way, we designed the denominators so they are exactly matching. The focus is on the numerator. So numerator of this one, I just write it here, which is 2x plus 3. And the numerator of this one here, which is a times x plus 2 plus b times x minus 1. Note that I want to make sure that I'm rewriting this function, or basically this function, as a summation of two functions. And I'm not just finding them for a specific x, finding one equation that's valid for one specific x value. I want to make sure that these two are always equal to each other, no matter what x is. So this gives me the freedom that I choose x values and then test that here. For example, I know that if I plug in x equal to 0, the left hand side and the right hand side should be matching. If I plug in x equal to 1, the left hand side and the right hand side should be matching. So, but what are some of good or easier x values that I can try? One of them would be what makes this bracket 0, which means x equal to -2. Let's just try that. If x is equal to -2, I just, let me just move it here. I can rewrite this one. So I have 2 times negative 2 plus 3 is equal to a times negative 2 plus 2 plus b times negative 2 minus 1. Now that this bracket is 0, this part entirely disappears. Now I have a very simple equation. So I have 2 times negative 2, which is negative 4 plus 3, which is negative 1. And the right hand side is b times negative 2 minus 1, which is negative 3. So it is negative 3b. So from here, I can conclude that b is equal to 1/3. I simply divide both sides by negative 3. And now I simply find a in the same method with the same method. So I plug in x equal to 1 this time because I want to make sure that this term disappears. So I get 2 times 1 plus 3. I plug in 1 here is equal to a times 1 plus 2 plus b times 1 minus 1. Again, this part goes away. Now what I'm left with is 2 times 1, which is 2, plus 3 is 5. And the right hand side is 3 times a times 3, or just 3. From here, I can write that a is equal to 5 over 3. Again, dividing both sides of these by simply 3. Now that I have a and b, basically I found a and b, which if I plug them here into these two fractions, the summation would give me what I started with, my original function. So let's just do that. So now I can write the original function that we had, which was 2x plus 3 over x squared minus x plus 2. Plus x minus 2. It's easier if I copy paste that. So this original function that we started with, and now I can write it as a summation of two fractions. One of them has a denominator x minus 1 and the other one has x plus 2. The one which the denominator is x minus 1, the numerator is a, and I already know what a is. It is 5 over 3. And the other numerator is b, which is 1/3. Now, instead of taking the integral of these, I can take the integral of this summation. And because it's a summation, I can split the integral. I can make it as summation of two integrals. Now it's way easier because in the first integral, I can take out this 5 over 3. I get 5 over 3 integral of 1 over x minus 1 dx. And in the second one, I can take out 1 over 3 out, 1/3 of integral 1 over x plus 2 dx. And now, because these are simply linear functions, these are the power of x is just 1, integral of them would be ln, natural logarithm. And if you want to do it properly, you can apply u substitution here. Let's call this part u and continue. And the same thing goes here. You call this part u and you continue, and you would get ln at the end. So what we get is 5/3 natural log of x minus 1. And make sure that whenever we are dealing with ln in integrals, when the result of an integral is ln, we have an absolute value plus 1/3 of ln, or natural log of absolute value of x plus 2. And because the integral that we started with was indefinite, it didn't have any bounds, we just added plus c at the end. There are other ways to write this integral. Just write it as 1 ln, but really it doesn't matter. It's just not making that very simpler. So this would be the final answer to the